Good morning, good afternoon, folks. Do we still have the energy? Good morning. Amazing. Thank you so much for responding. Otherwise, I would have slept on the stage. Yeah, very awkward for all of you sitting here to see me sleep. This is going to be a very exciting one. I'm not going to dive deep into OpenSearch, but I'm going to tell you how all of you can potentially run local AI models on your machine and leverage OpenSearch vector database possibilities. And the best part is I have only demos, right? So the first thing that we have to do together is you all have to stay with me. If the demo doesn't work, what will we do? If the demo doesn't work, there is only one thing we can do. We'll blame it on the menu, right? Or blame it on the internet. Okay, are you all with me? Okay, let's get started. I'm going to talk about how you can leverage OpenSearch with Gaia. I'll tell you what Gaia is, how you can leverage Gaia in your daily workflows. Remember, all of this is local inference, so don't worry about sending your data to a black box. We are not talking about black boxes today. We are only talking about how you can run inference on your machine. I'm going to show you how I'll do that on my machine so that you can take this back to your workplaces and try this out. Okay? The only request that I have from all of you is make sure you have your phones ready, because I have a bunch of QR codes that I'm going to show. Firstly is, of course, if you want the deck, please scan it. It will appear multiple times through the session. But let's get started. I'm Harish. I lead developer relations at Gaia. I've organized over 200 hackathons in the last decade and quit running hackathons last year and joined Gaia as the developer relations folk. Right? What do I do as developer relations is pretty much share what you can do with Gaia with multiple other platforms, both Web 2 and Web 3. I don't know how many of you are Web 3 enthusiasts here. Any Web 3 enthusiasts? Oh, not bad. Thank you so much for coming. Right? For all you Web 2 folks also, this is going to be very relevant. With that quick intro and quick branding, I'll move on. Right? How many of you have used an open source LLM? Show of hands. Oh, nice. Good crowd. Okay? And how many of you have tried running LLMs locally? Raise your hand. Oh my God. I hope this is not going to be redundant, but I'm sure it is going to be exciting. I have one more question. How many of you have tried bringing models from Hugging Face and used it in OpenSearch? Oh, we have quite a few people. Nice. Last question. How many of you have deployed custom inference pipelines in OpenSearch? It can be with OpenAI, it can be with Claude, AWS SageMaker, right? Today it's going to be about Gaia. All right, what is Gaia? Gaia is, with all this beautiful jargon that you can read, in simple words, if I were to say, Gaia is the bare metal of AI, which is an open source framework that you can run fully locally on your machine. When I say machine, it can be your computer, it can be a Raspberry Pi, it can be a mobile phone, it can be an AWS server, it can be a GCP instance, it can be anywhere. You can run this fully locally, right? But all you need to do is, if you have Windows, I'm sorry we don't have support yet. Windows is amazing, but please install WSL if you want to use Gaia, right? Tomorrow don't complain to me on Twitter and say, oh, you said you can run it anywhere, but this doesn't work on Windows. I'm going to tell you, please install WSL, right? Okay. So what will happen when you run a Gaia instance on your computer? You get all these components. I hope you are able to read this, but I'll give you a quick overview of what these are. What you get when you install the Gaia CLI is you get an LLM. By default, it is Llama 3.2, but you can customize it. I'll show you how to customize it to use any other model from Hugging Face, because I asked that question, I have to show now, right? It's on me to show you how to run any model. Then you also get Prompt Manager, where you can customize and tell the LLM how to behave, right? Because LLMs are dumb. You have to tell them, spoon feed them what they have to do. Then by default, it also comes with a quadrant vector database, but in today's session, I'm going to show you how you can use OpenSearch's vector database capabilities, right? Along with this, basically this whole thing runs on what is called as a Wasm Edge runtime. How many of you have heard of Wasm Edge? Wasm Edge is a very lightweight framework that lets you run applications on edge devices. In our case, our machines, mobile phones, etc., right? And whenever you launch a node, what we call what you launch with Gaia node is you get an OpenAI compatible API, which means if you today use platform.openai.com as your API endpoint, you can replace that with the Gaia node. It comes with a URL by default when you launch a node. Right, with all that out of the way, this is a QR code that you can scan and go back home or after the session if you want to try it out. This is how you install it. I'm not going to go through the installation process because it'll have to download the model, right? So what I've done is, for the sake of simplicity, I've downloaded the model by default. I'm going to show you how to run it, right? Okay, so what can you build with Gaia? Very high level, you can build decentralized applications. I also said OpenAI compatible API, which means you can build chat applications, you can integrate it with anything that you already have in your pipeline, or build new applications on top of it, or give it a custom knowledge base and build custom personal agents, digital twins, or even plugins, right? And integrations. For example, today it's going to be about OpenSearch plus Gaia. With that out of the way, let's see the demo, yeah? How many of you want to see the demo? With all that technicalities out, thank you so much. Okay, let's go to the demo. Okay, still here. Like I said, when you launch a Gaia node, there are 3 simple steps that you have to follow. One is you install the CLI. This is the command to install the CLI. The links are all in the presentation, so don't worry about not knowing where I'm going to show you all this from. Once you install the CLI, what you get is the Wasm Edge runtime. You also get the Llama Edge runtime and all of that. And then you do Gaia init, which initializes and downloads the default model, which by default is Llama 3.2. But now I'm going to show you how that you can customize. So when you install a Gaia node, what you get is this folder. So if I were to go into this folder, like you can see, there are a bunch of things. The main thing that you have to see is this one, which is the embedding model. Right? You can use this model to convert embeddings. And then there is the large language model itself. For today's demo, I'm going to show you Quen. Apparently, it is pronounced Quen, but I prefer saying Quen. Quen 3, 4 billion parameter model is what I'm going to show you as to how you can analyze your OpenSearch data using Gaia. Right? Why this model is because this model has thinking capabilities very similar to DeepSeek. You can also run DeepSeek, but I'm not going to try running DeepSeek because it's a large model. Compared to this one, I'm going to use a small model for the sake of simplicity, right? So that's what you get. And the last command that you have to do, like I showed before, is GaiaNet start. And what this does is initializes the node and uses something called as FRPC. I don't know how many of you are familiar with FRPC. What it does is assigns a URL to your node. So once this is done, you should see a URL where you can start interacting with your node directly. And then we'll take that URL and use it with OpenSearch to fetch data from OpenSearch and provide it to the LLM and then say, give me insights, right? Okay, let's wait for this to complete. And let's get back to it once we have the URL. Any questions so far? Raise of hands. No questions? All good so far, or you have no idea what I'm talking about? Oh, wow. Okay. It's great feedback, folks. But it's okay, we can still take questions, or if you're hesitating in the large audience, you can come talk to me after this. I'm not that intimidating in person. Right, while this is happening, what else can we do? That's it, I think it's done. So you get a URL, right? That's all. Now you have a large language model fully running locally on your machine. It's completely running from the GaiaNet folder that I showed you. Right? By default, you also get a chat interface. This is the curl command that you can use to do the chat completions, typical OpenAI style chat completions. Right? When you click on chat with this node, you can start talking to the node and customize the system prompt and all of that. So I will say start, and then you should see there is a prompt called system prompt where you can customize how you want the LLM to behave. By default, this responds with a thinking response first, and then responds with how it is going to fetch your results, right? And then there is curl API. You can call the API directly in your terminal, right? So that's the node URL that you have to remember. Now we'll move on to my deck and continue. Okay. Oh, wow. So why local inference? Why should you use local inference? I think the reasons are pretty straightforward on the screen for you to see. Your data is never leaving your machine, or it is never leaving your OpenSearch instance that you are ingesting your data into. Then also the inference is very fast, right? If you are running on-prem inference. If you want to figure out how to run on-prem inference, your inference is going to be super fast if you use a local inference model. And it is super easy to set up. Like I showed, there are only 3 commands that you have to run in your CLI for you to be able to start getting started with running local inference. And of course, there's only a fixed cost that you pay for your GPU, or if you're running if you have a MacBook with at least 16 GB RAM, you don't have to pay for any new tools or providers. Right, you can use this URL right now in your phone also to be able to talk to it, right? The best part is you can also run this locally. If you don't want the URL, you can just pass local only parameter and you will be able to run the entire inference fully locally. So it is not even having a URL that you can share, right? So those are the primary advantages. Like I said, we are not going to give data to black boxes. So that's the whole premise of this conversation today. Okay, so the first step that you have to do in OpenSearch instance, when you launch an OpenSearch instance, is whitelist the URL, right? This is the trusted connector that you should provide, the last one, so that your Gaia URL, when you launch a node, is now available inside OpenSearch, right? After you do that, you have to create a connector. How many of you have done this process before? Creating a connector, then attaching to a model and deploying it, right? Same process. You do the same thing, but instead of OpenAI, you use Gaia, right? You provide the endpoint. There are no API keys if you're running this locally, but we do have public nodes if you want to consume inference from a URL, but I wouldn't recommend because it's similar to OpenAI, right? The inference time will be much higher compared to running something locally. So you create a model, and then what you have to do is deploy the model, right? Provide the connector ID that you got from your previous command, and then the last step is test the inference. Just say what questions you have, and you can test the inference. Now, of course, how is this attached to OpenSearch, right? You are running all of this in the OpenSearch panel itself, and then the important step is for you to create the pipeline, right? In this case, I know it's hard to read, but I'm only defining what the pipeline does. It is basically doing RAG, right? Retrieval-augmented generation. And then I'm saying this is my default flights data that you get when you launch an OpenSearch instance. So I'm saying these are the values that you need to provide and somebody is calling the search API. And the last one is, of course, prediction, right? From the results that you get from the search call that we did before, you have to take those results and provide it in the content to the LLM. And then the LLM will respond to you, right? That's all. That's all you have to do when you want to run inference with Gaia. But I said I have demo, right? So for the sake of demo, what we're going to do is I'm going to show you a Python application. The GitHub repo for this is also available in the deck. You can search for it, run it on your own machine. But what I'm doing with the GitHub repo is, the first step is I've ingested airline reviews data. There are about 80,000 lines of reviews already in the locally running OpenSearch instance that I have on my machine. And then I'm saying search these few fields that you can see. This is the best part, right, of OpenSearch, is you are able to do multi-keyword search or multi-key search, essentially, right? Then I'm getting the hits parameter. I'm going to show you the code for this, don't worry. I'm going to show you the demo as well. Then I'm getting the the hits from the response, and I'm creating a prompt, essentially. That's all I'm doing. This all looks complicated, but it is written by AI, so very straightforward, yeah? How many of you are not using AI to write code? How many of you are lying for my previous question? Okay, if you are using AI, yeah. But yeah, the idea is very simple. You fetch the results from OpenSearch, frame it into a prompt, and then give it to a LLM. That's all you have to do. Why LLM? Anybody? Why are we using LLM in this case? Exactly. Because you can create dashboards, you can create graphs. All of that is possible with OpenSearch, but can you create natural language based insights, right? That's the premise of my entire demo, right? So once we convert this to a prompt, what we're doing is sending it to the endpoint, which is the URL that I showed before. I'm saying you're an airline industry analyst, provide insights based on the data that is given to you, and under the user prompt, I'm sending all the data that I got from my previous search reviews call, right? How many of you are with me so far? Are you all understanding? Okay, thank you. That's it. Once you get the response, there is a demo for you to see. Let's go to the demo. Okay, I'm running this locally. If you all don't trust me, my OpenSearch is running here locally, and I've built a simple Streamlit application that is also running locally, and I'm now going to show you how to call this, right? Any specific questions folks want to ask the LLM? These are reviews for airlines. Any ideas that you have, or you want me to just show you how it works? If there are no responses, I have all the prompts saved. So I'm going to copy one of the prompts, right? A random prompt. And I'm going to send it to the LLM. Now what this does is fetches the reviews from my locally running OpenSearch. Like you can see, you can also configure the results per query. You can also make it 100, but I would not recommend it. You start with small ones. And then once you have the reviews, it also creates graphs. Beautiful graphs. I know not as beautiful as what you get on an OpenSearch dashboard. But what it is now doing is sending the prompt that we created from the responses that we got to the Quen model. And that will give us two responses. One is thinking response, and the second one is the actual response of how it acted upon the data that we provided. That's all. Thank God the demo worked, yeah? Demo gods are with me. Like you can see, this is the thinking response as to how the LLM is thinking and what it is doing with each of the parameters that it received. And then you have insights. Now you can customize all of this by customizing the system prompt. Remember, there is no complicated science behind using LLMs. All you have to learn is to prompt better. If you are able to prompt better, your responses are better. It's as simple as that, right? Everything is abstracted away. Don't worry about how the model is created. If you are somebody who's a crack dev, when I say crack dev, somebody who wants to tinker everything, then you worry about how to create an LLM itself and all of that. But if you want to consume inference and generate insights very quickly, you don't need to understand all of that. Understand how to write better prompts and get the responses. Any other questions you want to ask the LLM and see how it responds? No questions? Have you guys not eaten breakfast? What is happening? Huh? Oh. Okay. Yeah, so typically we've seen large language models evolve from, so the question is, what is the difference between, you can ask in the mic for everybody to listen.
Yes, so we got two responses from the model. So what is the difference between the internal reasoning and the actual response? Actual response, we got it, but you can detail on internal reasoning.
Yeah, I think we've all seen large language models generally evolve from directly responding, and then we saw DeepSeek, which brought in the phenomenon, if I were to say, of showing how the model would actually think. Now this gives us as developers or builders who want to consume LLM inference to be able to customize how it can think. Yes. And then use the thinking response to send it to an external third-party API also. So that's how you can use it. But now you can also see how the LLM is taking each of the data points we've provided. So if it is understanding a data point very differently from how we want it to understand, you can customize it, saying this is how you have to think. So that gives you more power to be able to customize the LLM to prompt and get better responses. That's the primary difference. You can also disable this in the Gaia node. I'm going to quickly show you. I'm glad you asked. Thank you so much for asking. I'm going to show you how you can disable this. I'm going to show you each code that you get with the Gaia node. Let me zoom in so you can see. The primary file that you can customize when you're launching inference with Gaia is the config.json file. And inside this, there are two types of prompt templates. The chat.ml template is very specific to the Quen model. Now you can also do Quen 3 -no-think, and then it'll only respond. It will not think. It will not give you the thinking response. It will not evaluate how it is going to act on the prompt that you gave it. Right? So that's how it helps, essentially, for us as builders and developers to customize how it is thinking. This is where you can also customize, right? You can see what the system prompt is. You can customize this, run in it, and then quickly run GaiaNet start, and it'll update everything. Like you can see, everything is sitting here. Hugging Face is where the models are. I can quickly show you what models you can use. You can also use DeepSeek. I think we launched DeepSeek this week. So you can use DeepSeek also, which is a distilled version for Qwen 3. Similarly, there are VLMs, there are LLMs, text-to-speech models that you can run. So the applications are enormous that you can use today. We also support Google's Gemma models. So if you are somebody who prefers Gemma, why Gemma? Because Gemma has a larger context compared to Llama 3.2 or the one that I'm using. It has 200K token size as the context. How many of you know what the context size is? If you don't know, I'll just quickly give you a very high level. If I would take the privilege to make it simpler, context size is basically how much an LLM can remember for that specific question. That's all. So if you send it an entire code base to understand how the code is written, and it is beyond 200K and you're using a Gemma model, it will not be able to understand beyond the 200K tokens. So it is up to you now to figure out which LLM should I use. If you were to ask me, one of the questions that I commonly get is, which model should I pick? Right? If you're generally generating insights, pick the latest Llama model or the Qwen model. They are really good at giving you insights and understanding the context of the information that is provided to them. Of course, Gemma 3 is also really good. But if you're building something to generate code, right? Let's say you have a large code base in your corporation that you want to create inference for that can support writing documentation or updating or fixing bugs and all of that. I would highly recommend using the Qwen 3 coder model. The coder is the specific model from Qwen. And then I would also recommend Mistral's Codestral. That is also a really good model that you can use. All of these are open source models. I'm not talking about any black boxes here. All of these are open source models that you can get from Hugging Face, and just copy the URL, put it in your node, and then run inference directly on it.
Hey Harish, we have a question here if you don't mind.
Yes.
Yeah, so I wanted to know, like, what was the difference between the data that we used to enrich the prompt and the one that we sent as a JSON dump to prompt to refer to?
Oh, okay. Thank you so much for asking. Let me show you the data that I sent to ingest into OpenSearch, right? If I understand correctly, right?
Yeah.
So this is the data that I ingested into OpenSearch, right? There are multiple values here. One is the title of the review, who's the author, where did the author write this review from, which year, and what is the actual review. Now the data that I send is the review itself, and some of these other values that I have in the data, which is what is their rating, what is their overall rating. What I've done is I've converted this to the prompt, right? If I were to go back and show you the specific slide deck where we converted this to a prompt, is this one. So I'm combining all of these to create a prompt, all of the values from the data, and say this is the context of the reviews that we have received. So we are not sending one review. We're sending a bunch of reviews. In this case, it is 10, right, in the demo that I showed. So we're sending all of these reviews together to the LLM and saying, now give me insights from this. Right? It can be e-commerce orders. It can be any form of data that you have in JSON or ingested already into OpenSearch. You can just fetch that using the /search URL in the JSON environment that you have on OpenSearch and simply send it to the LLM. That's the difference. So we are not sending raw data, but we are sending a prompt, essentially.
Thanks.
Yes. This has to be interactive, folks. I don't have more demos to show you. I'm so glad the demos work. But please ask questions. I think if you ask more questions, we'll have more understanding together.
Yeah, so my question is around the quantization. You used a 4-bit quantize model, right? So have you seen a difference between the different quantization models, specifically with Qwen?
Yeah, I prefer using Q5 in general because this one is much faster compared to the other ones in general. The other ones don't really respond specific to the data provided to them. That's the difference I've seen. But if you were to ask me, since Llama doesn't have a thinking model out yet, Llama 4 does it, but it's a multi-model model, which we don't support yet. We support text generation, which is, I think, very in line with OpenSearch. But the responses are better with this specific one. So all my demos are with quantization 5. Yeah.
Hey, question on the GaiaNet, the platform. So when you started up your node, you said the node is reachable right now. It's running on your Mac.
Yeah.
What if I don't have ingress capabilities? Meaning ingress is blocked on my Mac, but I can egress. Would it work then?
It works on Apple Silicon purely on the GPU.
No. I'm not talking about I'm talking about the platform, the reachability of your.
Okay. Pretty straightforward. So I'll show you what the code looks like. What it does is very simple. It uses FRPC. This is where you can customize. So you say local only, then it will not give you the URL.
No, my question is my request directly reaching it, or the node is reaching up to your GaiaNet to receive instructions?
Oh, okay.
Is it a top-down or a bottom-up?
It is always bottom up.
Bottom-up, okay.
Yeah. And what happens when you send the prompt is, in very simple language, is it converts it to embeddings first, and then uses the embeddings from the prompt or the knowledge base that we have, and then matches the distance between the vectors.
Yeah, I get it. I think my only concern is the amount of bandwidth that we're going to use if the context grows, because the agent needs to reach out to your network, get all of the data to the model that's running here. So it's a boatload of yeah.
You are absolutely right, which is why I would recommend running local only. I'm going to quickly show you the command for it. Okay. You pass local only, you get a localhost 1. So it is running fully locally. There is no URL or network call like you asked.
Got it. Thank you.
Yeah. Thank you so much for asking.
Hey, hi, Harish.
Yes.
I have a question here. So my question is mainly around the capability of the model to have or to take the user input as a kind of action that the model wants from the user. Let's say what happens is that I've seen with the AI models that they hallucinate, right?
Yeah.
It's very useful if they can take the input from the user, right?
Yeah.
And on the interface, on the UI interface, I can show an actionable item or a card to the user where they can provide the input. So I just wanted to ask you if the model has the capability to keep the human or the user in the loop while having the conversation.
So there are multiple ways to go about it when you're doing this with Gaia. One is you can, like I said, you can provide the snapshot, which is essentially the knowledge base.
Sure.
Saying don't use your pre-trained knowledge, but use my knowledge base. So what happens is, like I said, it converts your prompt into embeddings. The snapshot is also embeddings, so it will match only using the knowledge base. And this helps reduce hallucinations. But if you ask a question which is out of context and doesn't exist in the knowledge base,
correct,
which is your question, right?
Yeah.
That is when generally it tends to go to its pre-trained knowledge and then respond. But how do you handle that is purely through prompting.
Okay.
So your prompt should say only respond back to me. It's surprisingly very simple and not complicated. All you have to do is say only respond from the knowledge base that is provided to you, or only respond based on the user's input that is provided to you, and it will respond based on that. Otherwise it will say I don't know.
So it's a single shot that is going on, not a multi-shot thing.
So what you can do with OpenSearch is you can create a memory in OpenSearch,
correct,
right? And use that memory and use the RAG search pipeline earlier that I showed for it to have multiple contexts as memory, saying what was the previous question that was asked.
Correct.
Now, if you were to ask me how can I do this purely just on the AI inference level, in the config file, what you can do is tell the LLM how much context window that it has to store. If you want it to store 5 responses, it will store 5. Right? This has got nothing to do with your machine. The only thing that has got to do with your machine is the context size. Right? You can reduce this or increase this based on how much powerful machine you have that you are running the inference on.
Sure. Just a follow-up question on that. Does the model have the capability to, like, just extending on the last question, right? Does the model have the capability to take inputs back from the system is what I meant initially. Like, if the model is not sure about something, right? Do I have the capability to take any input that I want from the interface or a user interface, let's say?
Yeah, the typical way I go about making that happen is, let's say the model doesn't know and
correct,
it says I don't know. What I do is provide more context, more information. So when I'm fetching the data itself, in this case, in our example, I'll fetch more data and increase the data so that the model has some context. Let's say we're talking about American Airlines as a question in our prompt. It doesn't have any data from the search retrieval that it did from American Airlines. Then you have to fetch more results.
As an example, let's say if I want to build an interface on top of this model, right?
Yeah.
And I ask for the graph, and I say that I want to add this graph to the dashboard, OpenSearch dashboard. I might have multiple dashboards on the OpenSearch. Does AI have the capability to ask me back, like, which dashboard I want my graph to add?
No.
Okay.
Not
sure.
yet.
Sure. Thanks.
Yeah, here. Hold on. 1 second. Yeah.
Yeah, so I have a question. So how Gaia is different from an application? Suppose I am building an application which is using OpenSearch to get the results, and then maybe I am using any model from OpenAI to query based on the natural language, right? And that is running in production. So my question is, how Gaia is different from this use case, and why would I use Gaia for this kind of a use case over a traditional application where I already have OpenSearch and OpenAI models or any other models?
Thank you for asking. I think it is very relevant to why I brought up Gaia in this context is, Gaia you can run locally, right? Your knowledge or whatever you provide to the AI is not leaving the machine where you're running the node, right?
Okay, yeah.
Point 1. Number 2 is you have more freedom of the different types of models that you can use and not rely on just one specific model that the other providers provide. Right? GPT, they are good. I'm not saying they're bad, right? But you have the freedom based on your specific use case to pick a very specific niche LLM model, right?
Yeah, but I think that would happen during the, let's say, exploration phase when I'm exploring something in locally.
Yeah.
But let's say now I have concluded that this is the model that works for my use case and I want to take it to production. So do you recommend using Gaia in that case as well, or is it only for the local?
Oh, no, absolutely. You can fully run this entire thing using Docker on any cloud and make it go to production. Use it in production.
Yeah, so that's where my question comes. So if I know that this is the model that works for me, I want to take it to production, want to run in Docker, right? Why would I use Gaia in that case? Because that can also be done with, what I was talking earlier, without Gaia. So how Gaia does fit into this whole ecosystem?
Like I said, you have full control of the entire AI inference itself in your hands, which you don't have with OpenAI or Claude. You're heavily reliable or reliant on, let's say, Claude's Anthropic specific model, Sonnet 4, right? But you in this case are deciding which model you want to use, right? There are no other frameworks that let you run inference with this level of control. Sure, Olama is a platform where you can run local inference and all of that, but you can't do production with it.
Yeah. Can you expand a bit on this, that you don't have a control on the model? Because I think, as I understand that I've already selected the model, right?
Yeah.
Let's say Coin 2 or Coin 3.5. Let's say if I'm using that model in production, which is giving me the great insights, if you can elaborate more on that topic, that would be really helpful.
So when you said you decided Quen 3 or Quen 4 as the model, you're using it in Gaia only, no? How else can you are you able to call inference from that model? It is already sitting in your node, right? You can't call a Quen model with OpenAI. You can't call a Quen model with Claude.
How about any other model that are available by Hugging Face if I use?
Yeah, you can use any model, but you can't call them directly with an API, right? They are not OpenAI compatible APIs.
Yeah, see, maybe let's not talk about OpenAI, but I think any other interface that are available.
You can use them. What I'm saying is, this level of control is not available with them.
So what is that level of control that you're talking about?
One is specific knowledge base, like I said. You can provide a specific knowledge base in the snapshot. This is not generally available with any LLM model. All LLM models in Hugging Face have an endpoint that you can call and get responses, but you can't restrict them to specific knowledge base. That's one major difference, right? Not all LLM endpoints have an OpenAI compatible API. I'm not talking about OpenAI, but the API itself. Which means wherever you see OpenAI as an example inside OpenSearch, you can replace that with your node URL, right? These are the major differences. I think they play a significant role on how your LLM behaves.
And what if I get, and I think this is the last question, sorry,
no problem.
Going further, but let's say if I have got the responses from OpenSearch and I've got like 10 results, and then I'm prompting the LLM with this as an additional context. So this is my query. So please use the below context, and there is the context that I've got from OpenSearch to give me the response.
Yeah.
I think similar is what I think we are talking about in the snapshot. Is that what you're saying?
Yeah, that is the example I was saying. Now you can also do, what you can do is, let's say there is a large amount of data. Like I said, LLMs are bounded by context size. Now if your data is beyond the context, what you can do is call your Gaia node's embeddings endpoint and create embeddings and put that in the snapshot.
Oh, so that kind of configuration is available in Gaia?
Yes, sir.
Thank you so much.
Any other questions, folks? Yes.
So I'm just curious further on the snapshot part. So when I have a large, say, corpus of knowledge, are you generating the embeddings beforehand and keeping that in your vector store current and then implementing a RAG, or are you doing that at runtime?
So how I do that generally is first build embeddings for whatever knowledge base I have in whatever format. So in our documentation, we've provided multiple ways to do it. It can be a PDF, it can be a CSV, but you create embeddings first and then create the snapshot for it. You can put it in your local machine and put the path for it in the snapshot, or if you want to host it on a Hugging Face, you can do that. So here is where you can find all the examples, right? So this is how you create a snapshot, and by the end of this process, you get a .snapshot. After that, you launch a Gaia node.
Okay, so this snapshot is referenced by Gaia directly.
Yes.
It's not using current here.
No.
Okay, so if I have to implement a RAG, I'll need to keep generating snapshots again and again if there's a fast-moving data?
That's one way to do it. The second way is tool calling,
Okay.
or MCPs. So if you have an API for the data that is constantly changing every day, let's say the most common example is orders on e-commerce platforms, right? That is changing every day. What you do is tool calling to get the most relevant data. But historical data you can put as a snapshot.
Okay, so then what does current do here as a vector database then?
That's where the embeddings are stored.
And what does snapshot do? So you're not using snapshots to be stored in current at all?
Snapshot is the format that is stored in Quadrant. So
Okay, got it.
yeah. Hold on, let me see if I can show you Quadrant so that you get a picture of what this looks like. Do I have Quadrant? I don't think I have Quadrant. Oh, I have. Yes. But you can do this with OpenSearch so that you don't have to use Quadrant.
Yeah,
So,
I'm assuming you can use
You've seen
any
this
vector
before, yeah?
database, yeah?
This is the collection, and inside the collection is the data in the form of a snapshot.
Okay, got it. Understood. Thank you.
I think we have time for a
Yeah.
couple more questions. for
Yeah.
sure.
In the meantime, I'll put up the QR that you can get the tutorial from.
Okay.
Maybe you can use this for the GitHub repo. Yes.
So on that follow-up question, right? So Gaia product which you sent, right? So can we replace with LLM APIs and then use that context and then all these things, right? So I mean, I agree that Gaia gives more control on changing some model like prompts. Is that something like that, or like when I use Olalama to connect to the model and then everything I need to go with Python and then I need to change it. So this is the tool outside as an interface which is easily tweakable, that parameters. Or like if I use Olalama, I need to go and then compile all this information. Is what I can understand, or like how you can?
No, I think you understood it almost perfectly. Olama lets you run any model locally.
Yes.
And gives you localhost URL for you to consume the inference.
Yes.
But that's where Olama ends. What we are saying is you also get a URL. You also get to customize the knowledge base. You also get to host this wherever you want and not essentially just the local host. Right? And build applications on top of it. Today we have seen how you can call data from OpenSearch, send it to a Gaia node, and then get responses. Right? Python is one example that I showed. But there are multiple ways to do it. You can put an embeddable chatbot in your website, internal websites, right, where your team can chat with the node. Right? All of those are possible with Gaia, not possible with Olama. Olama lets you run and test out the latest models. Yeah.
Okay. So, and another follow-up question is it integrated only with OpenSearch, or is I can any other vector database I can integrate?
You can use any other vector database. If you go to my GitHub repo, you'll find PG vector as an example that you can use. Quadrant already comes by default that you can use. In our context today, OpenSearch is the platform that you can use to generate vector embeddings and all of that. So you can use OpenSearch. Let's say you want to use Pinecone. You can also use Pinecone because every vector database has a API or a URL for you to be able to call and fetch the embeddings. You can do that. By default, we are saying these are the values so that you can quickly get started. But it is up to you. Depending on your context, you can customize this entire thing, remove the components that you don't need, and all of that.
Yeah, that's cool, actually. Yeah. Thank you.
Yeah. If all of you have scanned this code, I think you can get the slides here.
Any other questions?
Yes, there are more questions. Thank you so much for everybody for asking these questions. That makes my session
Sorry,
enjoyable.
I have one more question. See, one of the largest problems problems with LLMs is it's not deterministic.
Yes.
If you ask a natural language query,
Yeah.
you may get it like 9 out of 10 times, and there's a problem. How do you control the deterministic aspect of it using Gaia?
I think there are multiple ways to go about it. One way with Gaia is just purely playing with the system prompts. But what I would recommend is if you have a very specific...
Sorry to interrupt
Yeah.
you. I get it. The system prompts is
Yeah,
something
yeah.
I play with. But when you talk about production-ready applications,
Yeah.
that's where you cannot change the system prompt again
Yes.
and again.
Yeah.
You don't want my customer to say, what is the
Absolutely.
value of a stock, for example?
Absolutely.
And I say X today, and maybe 5 minutes later I say something else, right? So
Yeah.
how do you control the determinism of this?
So, especially for the use case that you mentioned, which is stocks, right? Yeah, it could be anything. It could be e-commerce orders like we discussed before. For those use cases, what I would recommend is using an MCP or tool calling to get the most relevant recent data, if that is the context. The other thing that I would recommend is, let's say you pick Qwen3 model. What I would recommend is before you go run this node, fine tune it using Unsloth. You fine tune the model so that it becomes better at responding to your specific data. Otherwise, these are all generic models that you can get started using with. But fine-tuning, I think, is the way to get LLM to better respond to your specific knowledge and data set. Yes. I think this will be the last question. I'll be around if any of you want to come and talk.
Yeah, so I saw you using Hugging Face, but models under GaiaNet.
Yeah.
Yeah, so I can plug in anything under Meta, or is it some compatibility that only you guys are hosting that in your Hugging Face?
Correct.
That
As of today, we host about 200 plus models.
Okay.
GGUF models specifically are supported by Gaia.
Okay, so if, for example, Meta releases a new Llama model.
They all release GGUF, so you can directly use them.
Okay, got
Yeah, I didn't show Llama because Llama is the default one that you get anyways with Gaia.
Okay, thank you.
Thank you. All right, thank you so much, folks, for sitting and listening to me. If you want to ask questions, I'll be around. Thank you.